Square wave of time period 80 microseconds can be obtained from a square wave of time period 10 microseconds by using. Here we know that in case of a mod n counter, f in f out, which is equals to f in by n. So T out is equals to n T in. So here T in is 10 microseconds, T out is 80 microseconds. So n is equals to 8. This is number of states present in a counter. So if we take option A, that is 3-bit parallel counter, there are 3 bits means 8 states are possible. In case of B, 16 states are possible. In case of C, 16 states are possible, and in case of D, 2 power 8, 256 states are possible. So option A is the only option correct. User states in 3-bit Johnson counter is here. If in case of an n-bit Johnson counter, there are 2 power n states, that is 2n states, but the number of states possible are 2 power n. So the number of unused states is nothing but 2 power n minus 2n is equals to unused states. So here n equals to 3, that is 2 power 3 minus 6, that is 2 states are the unused states, that is option B is correct. 8085 microprocessor, which one is the longest instruction among the given following? Here, out of 74 instructions in 8085, call instruction is the longest duration instruction, which takes 18 T states, 5 machine cycles. So option A is correct.
It is given that A and B are mutually exclusive events, and we have to find probability of A plus B, that is nothing but probability of A union B. Now we know that probability of A plus B is nothing but P of A plus P of B minus P of A intersection B. Now as A and B are mutually exclusive, this intersection will be always 0. So the required answer is P of A plus P of B, which is nothing but option B.
Of e power j omega is a high pass filter, then h of e power j of omega plus pi is a. Here if we draw this one, minus pi to pi, this is the digital frequency, this is the high pass filter representation, this is cutoff frequency minus omega c. Suppose c is h of e power j omega. H of e power j omega plus pi means you are shifting to the left by pi, that is you are going to get this one. So it acts as a low pass filter, that is option A is correct. The DFT coefficients are given by 1, 2, 3, 4, 5. Then find the energy of the signal. We know x square n is equals to 1 by n, that is energy is equals to, this in time domain, this is in frequency domain, k x square of k. So here n is equals to 5 because there are 5 samples. So 1 by 5, 1 square plus 2 square plus 3 square plus 4 square plus 5 square, which is equals to 1 plus 4 plus 9 plus 16 plus 25. 1 by 5, that is 9 5s are 14, 30, 55, which is equals to 11, that is option B is correct. Response of an LTI system to a unit step signal is 3 by 2 of 1 minus e power minus 2t, then the impulse response of the system is. We know that del of t and u of t related in time domain as du of t by dt. So LTI system is nothing but input and output are linearly related. So if the input is really differentiated, then the output is also be differentiated. So if this is an LTI system, u of t we are getting 3 by 2 1 minus e power minus 2t. But to the same system, if we give del of t which is equals to the differentiation of u of t, so the output must also be differentiated, that is 3 by 2 1 minus e power minus 2t, which is equals to 3 e power minus 2t. That is option B is correct. Crossover frequency of a system whose open loop transfer function is, see, initially before we have to calculate the phase crossover frequency, we have to know what is the phase crossover frequency. Phase crossover frequency is the frequency at which phase reaches 180 degrees. That is, angle of G of S at S equals to j omega pc is equals to minus 180 degrees. So G of j omega is equals to 6 by 2 minus omega square plus j2 omega j omega plus 2. So angle of j omega is equals to minus tan inverse of omega by 2 minus tan inverse of 2 omega square. So at omega equals to omega pc, this is minus 180 degrees, omega pc by 2 omega pc 2 minus omega square pc. So if we apply tan on both sides, this is 0, tan 180 is 0, omega pc by 2 plus 2 omega pc divided by 2 minus omega square pc. So 2 omega pc 2 minus omega square pc is equals to minus omega pc by 2. This gets cancelled. Omega square pc minus 2 is equals to 4. So 6 omega pc is equals to root 6. That is option A is correct.
This AC voltage controller controls current in a purely inductive load. If the firing angle of the SCR is alpha, what will be the conduction angle? Okay, AC voltage controller converts AC to AC. Okay, so what is conduction angle? Conduction angle gamma is given as extinction angle minus firing angle alpha. Okay, since we have a pure inductive load, that means at pi it is going to have the extinction angle always. Okay, firing angle is given as alpha, so conduction angle gamma is pi minus alpha, which is option B.
Choose the correct statement. Option A, that is root locus method, is basically a one parameter method that is used to study the effect of varying any chosen parameter. That is correct. We can use the root locus method to study the effect of, that is total effect of varying two more parameters by doing the calculation sequentially. Yes, that is also correct. Root locus and root contours also having the property is same as the root loci. Hence all the statements given are correct regarding root locus. So option D is correct.